Today's lesson is lesson number 90. We're going to be talking about scatter plots, okay? So this is another way that we can think about statistics. It's our last little piece of statistics here, okay? So we have box plots, we did dot plots. These are scatter plots now. There should be a space here, sorry. So a scatter plot is a graph of plotted points that shows the relationship between two sets of data. Okay, so instead of just looking at hours studying or hours spent on homework or number of likes on Instagram, okay, where it's just one thing, now we're looking at two and seeing if they are related to each other. So do the number of hours that you spend studying, does that influence your GPA? Yes.
Isn't a scatter plot just like that?
Yeah, I'm sure you guys have seen these before, so today's lesson should be relatively easy.
So like the no correlation thing, so like when someone says something, you're like, oh, no correlation.
Yeah, I don't know. I haven't seen that, but yeah, no correlation is a thing. Okay, so make sure you write down this definition, okay, for scatter plot. And then we're going to go on to the steps. If you want to start writing them, they're on the board. We'll go on to them on the big slide in a second.
It's like that.
All right, so this is an example of a scatter plot. You can see we have study time down here and then test score. Okay, so I want you to turn to your partner and try to just discuss what you see here. Okay, is there any conclusions you can draw from this? How do you think they made this? Did they ask people like a certain question? What did they ask? Talk to your partner and just try to kind of analyze this graph if someone handed this to you. Okay, talk to your partner. All right, so what's something, guys back up here, what's something that we can say about this? Mark, you go ahead.
The dots look like a giraffe.
The dots look like a giraffe. Tell me more.
There's dots.
There's dots. Why do you say they look like a giraffe?
Because like if you look at the figure of like the dots, so it goes from like there, and then there.
It all kind of is together though, right? Like the neck part kind of, it all kind of stays together.
The dots on this one, it'd be a giraffe.
All right, we're not going to quite connect the dots. 1 second. But I do actually, what you're saying is kind of true. They all kind of are together. You can think of it kind of like the neck of a giraffe. But let's talk about what other things can we pull out with this context. Yeah.
They asked how much. They asked students how much hours they studied, and those dots are the score they got from the hours they studied.
Okay, so like as a result, so I'm thinking maybe as my research question, right? I'm thinking, I'm wondering if the amount of time that people spend studying will impact their score, right? So they went out and asked people, okay, how much time did you spend studying? And then they got their test score. Right? Maybe they looked at their test score or they asked them, what did you get on the test, right? So there's two different pieces of information that are combining to give you the 1 point. Okay, so each point is like one person. Okay, and what do you notice overall? What's kind of the trend? Is there something you can conclude from this data? If this was your project, what would be in your conclusion? Yeah.
People that study less get lower scores.
Okay, people that study less tend to get lower scores. Yeah. Or the opposite, right? The kind of the converse of that. So the people that study more tend to get higher scores on their tests. That's something that we would maybe expect, right?
How do you study for 5 hours?
Oh, that's a long time.
I don't understand.
Okay.
I don't understand life theater.
Okay, so these are the steps for how to create a scatter plot. So the first thing you do is you're going to be creating your graph in the first quadrant of the coordinate plane, okay? So this is just like plotting points that are x comma y. Okay, but we usually just use the positive, so we have positive x values and positive y values. So that would be the first quadrant, okay? And then you're going to identify one category as the independent variable. That's going to be your x-axis. And then one category as your dependent variable. That's going to be the y-axis. We'll talk a little bit more about that in a second. Okay, then you plot the data, so you do x comma y for each set of values that you have. And you'll determine if there's a relationship between the categories. Like on the example, right, we said, oh, the more hours you study, the higher your grade is on the test. So there was that kind of a relation between them. So let's talk about the independent and dependent, okay? So I like to think of the dependent one. That's kind of easier for me to think of, to determine, and then I know the other one is independent. So independent is it can kind of stand on its own. But dependent typically depends on the other variable, the other category that we're talking about. So for the example, we had study time and test score, right? It makes sense that the test score depends on the study time, right? That's kind of what we're hoping to show. So that's what we would expect, right? Is that the test score depends on the study time. Okay, so since the study time is since the test score is the dependent variable, that goes along the y-axis. And then since study time is independent, that goes along the x-axis. Okay, typically a lot of the time if we are dealing with time, so hours that you study or days that you go to class or days that you're tardy, okay, that's usually going to be our x-axis, that's independent, because that's something we can just kind of look at. We can just kind of see it is what it is, and then we can kind of try to look at things that depend on that. So maybe you have a lower grade because the amount of days that you're in school is low. Okay, so if you miss a lot of days, the more absences you have, maybe the lower grade you would have. So typically, if we do have something with time, that's typically going to be the independent one, and then usually other things depend on that. Okay, so when you're thinking of it, you just want to think, okay, which one depends on the other thing? And we'll see some examples. Did everyone finish writing down these steps? Mostly?
Yes.
Okay. If you need to finish up, they are on the whiteboard, all right? All right, so here's our first example. Just kind of look up here for this, and then we'll have some time to write it in our notes, okay? So let's say we wanted to look at the latitude of a location, say some major cities, and compare it with their average annual temperature. Okay, so I'm thinking which one is independent, which one kind of stands on its own, which one am I kind of looking for, and then which one depends on the other one. So if I'm thinking, okay, I'm going to stand in Russia, pretty far north, I have a high latitude, I'm thinking the temperature is probably going to be cold, right?
Yes.
But I'm picking where I stand, right? So, and then I'm seeing if the temperature depends on that location. Does that make sense? So the location or the latitude will be our independent variable, and then the temperature we think is going to depend on the latitude. So the temperature is the dependent variable, and latitude will be our independent.
I got it.
Okay, so in an experiment kind of situation, this is kind of what we pick, and this is what we're testing. That's kind of another way to look at it, okay? So we're going to pick the different latitudes, and we're going to test what their temperature is to see if there's some sort of a relationship. All right, so if this is my independent, that's going to be my x-axis. So I'll label this as latitude and label my y-axis as temperature. Because of my scale, I would have probably liked to break these up a little bit more, but I didn't have enough room to mark each of these off by 5, so I just went by 10s. Okay, and then for temperature, I noticed that the lowest temperature is 39.4, so just under 40, and the highest one is 82.6. So since all my temperature ranges are kind of between 40 and 85, I didn't want to include everything 0, 5, 10, 15, 20, 25, 30, 35, right? There's no values in there, so we can kind of squish that part of our axis if you use this little Z thing. It's kind of like just crunching it there. So I'm saying I want to crunch this and just start at 40. Does that make sense? Just kind of a shortcut so I don't have to waste a bunch of blank space. So if this is 40, then I go up by 5. So I have 45, 50, 55, 60, and so on. D, 60, 70, and 80. Okay, so here are my first couple of points. I'll plot these. So first I have 13.7 for latitude, and then the temperature there is 82.6. So 13.7 is about here, and then I go up to 82.6, okay, just like an x and y point in the coordinate plane. Okay, second point is 30.1, and I go up to 71.4, so I'm a little bit past 30. I go up to 71.4. Easy enough, right? Okay, I've just plot the rest of the points on here then. Okay, so I just plotted these, 7 points. Can anyone tell me anything based on this? Is there something I can kind of conclude now that I've created this scatter plot for my data?
No.
Marky looks bored. Do you want to just tell me? What can you say?
What?
What can you say about this data? Is there any sort of like trend happening?
No.
Yeah.
Yeah, what's the trend? It goes like this, right? It's kind of going down. But let's put it in the context of what our actual variables are. So this is, as I go up in latitude, what's happening with my temperature? It goes down, okay? So if we want to describe this situation, we would use terms like that, okay? So we would say, maybe as the latitude increases, we notice that the temperature tends to go down, or tends to decrease. Does that make sense?
Yes.
And this is true in real life. If you think about, remember, the equator is like 0 degrees, right? And that's typically really tropical weather, really warm. For latitude. 0 degrees in latitude. 0 degrees north, sorry. And then we go up from there, okay? So then the bigger one, so the higher degrees north you are, so something like 55.8, you're getting into northern areas, okay, like Canada, Russia. It's cold there, right? So we expect that the temperatures are lower. Okay? All right, so let's go ahead and write this down. So give a quick sketch at least in your notes. And make sure you write some sort of a sentence that explains what's happening in the data, okay? Okay, number 2 is talking about the size of an engine in liters compared to fuel economy, okay? So car that's for sale, it's like, oh, it's a 1.6 liter V6, I don't know, something. They're like, oh, average mile per gallon gets 40 miles per gallon highway or something, right? So we want to know, is there some sort of a relation between the size of the engine and the fuel economy, or the miles per gallon that it's going to get? Okay, so if you think like a big truck, or like even like a semi, right, has a really big engine. So the liter size is going to be really big. And we would think a big engine like that, trucks and stuff, they usually tend to get lower miles per gallon, right? And then if you have like a little car or like a motorcycle that has like a really small engine, it has a really small liter engine, and you tend to get a lot of miles per gallon then. Okay, so talk to your partner, tell them which one do you think would be the dependent variable and the independent variable. So which thing do you think depends on the other one? Okay, which one depends on the other one? Okay, Dolan, do you have it? Were you raising your hand? Which one depends on the other one here? Yeah, miles per gallon. That makes more sense, right? The miles per gallon, or the fuel economy, is going to depend on the engine size. So miles per gallon is the dependent variable. So that's kind of what we're testing. That's going to go on our y-axis. And then engine size is what we know, right? We can just kind of look at the different engine sizes. So that's going to be our independent variable along the x-axis. Okay, so it'll look like this. Okay, I've got engine size as my x, and then fuel economy as my y. Okay, now I want to make an appropriate scale. So I see the liter size goes from 1.2 up to 5.7. So I need to go like from 1 to 6. You might want to space this out and skip a line, so you could do like 0.5. I didn't have quite enough space here, so I just did 1 through 6. And then the fuel economy, I see 12 miles per gallon is my lowest number, and my highest number is 40 miles per gallon. So I want my scale to go from 12 to 40. And I did that by 5. So I just went up by 5s up to 40. Okay. I want you guys to sketch this in your notes then, and I'm going to have you come up and plot these points for me, okay? So you can get moving, right? So sketch it and then determine someone in your group of 4. Send someone up to plot one of these points. If you're the person that's coming up, just put an X next to the one that you plotted so that someone doesn't repeat that one. Okay? Okay, what can we say? How can we relate? Is there a relationship between these two variables?
Yes.
Yes, what is it?
As the engine size liter hours increase, those things
The fuel economy, you're doing so good. The fuel economy decreases. Perfect, yeah. So as the liter size increases, the fuel economy tends to decrease. Here are the points that I have, so we'll see if they kind of match up. Pretty close.
Maybe if we did all 10.
It looks pretty good, right? And then there was a couple that weren't done. Perfect, though. Looks good. So, again, still, it all kind of has that trend. What if, though, instead of just those points, what if I had, like, let's ignore these. Let me do them in different colors so I don't mess up. Let's do this. What if I had, like, points all here and here? What do you think? Can we say something?
No correlation.
No correlation. I feel like I need to know what you're talking. I don't know your like Twitter thing that you're talking about.
No, but
it's okay.
That's not 10, and we're talking 10. That's like 35.
I know. Yeah, this is if maybe we had more data and this is what we had.
This is probably where Earth is all.
Okay, listen.
Smog.
Okay, so if this was the data we had, we couldn't really talk about a trend, right? So here we would say there's no correlation or there doesn't appear to be a relationship between the two variables. That's right. Do people put like a picture of this and say no correlation, or they just put it when like something doesn't relate?
Like so.
If someone says something random.
Some guy, he was like.
It's all right. We'll talk about it later. But yes, it's real. It's math.
I'll talk to you about it in fifth period.
Okay.
I don't want to get
So this we would say there's no correlation or there doesn't appear to be a relationship between the two variables, okay? I'm going to go ahead and undo these red marks, though, because those were not pieces of our data, right? That was just to kind of think about it. So this is what you should have.
Would that be right skew?
We don't talk about skew for this, okay? So different thing, okay? That's more if we're talking about frequencies, like the other stuff that we did, right? Where there's only one thing that we're testing and we're looking at how many times that happens, okay? So go ahead and make a quick sketch of this. Give yourself a summarizing type of sentence. So say, maybe as the engine size increases, the fuel economy tends to decrease, okay? Or something to that extent. Okay, so up here, please. Okay, this is our last example. Let me erase the dots that we have on the board. This one I want you guys to make on Doceri, but first let's talk about which one is the independent variable and which one would be the dependent variable here.
independent is the hour.
Which one depends on the other one?
The ones on the right. The GPAs depend on the hours.
GPA depends on the hours that you study? Does that make sense?
Yeah.
Again, hours, kind of our clue, time, things that have to do with time are typically independent. That's typically going to be the x-axis. So study time is going to go down here, and then our GPA we think will depend on how much a person studies, right? So the dependent is the
Dang, that's good.
is the y. Okay. So let's label these. This is the GPA, and then the hours studying. It's just little. That's a G. Okay, so the hours studying goes for the x-axis, and then GPA for the y. Okay, so go ahead and pick an appropriate scale. I skipped one here, so I did 1, 2, 3, 4 like this, 1, 2, 3, 4 like this for GPA, okay? So that I could be a little more accurate with like the 0.5 and 0.25 hours. Go ahead and make this on Doceri and show me your graph when you're done. Alright, so it looks like we plotted them all correctly. I saw a lot of the same trend going on on everyone's graph. My points look like this. Okay, so what do you notice? What did you think when you were graphing? What's a trend? Someone raise your hand and tell me a nice summary sentence. Roman, go ahead.
Wow, the more hours they study, the higher the GPA is getting.
Yeah, right? The more hours spent studying, the higher the GPA tends to be. Is that okay?
Yeah.
So that's all we're really talking about right now. Tomorrow we're going to talk about how we can kind of approximate this and make a line. We're going to make what's called a line of best fit, okay? For now, go ahead and sketch this, and then turn and talk to your partner about what we learned today and how we do that. how it fits into mathematics, and how it fits into real life. I'll put it up here in a second, but I want to give everyone a chance to write this. Alright, and then at the end of the lesson we talked about some closing topics. So again, we learned how to create a scatter plot, and we do that by identifying the independent and dependent variables and then plotting the points appropriately. And it fits into mathematics. We've been talking about statistics this past unit, so it deals with data and graphing. We graph these points just like we would a regular x, y point. And in real life, there's actually a lot of applications here. Any of your survey projects that you guys did, you could always include another set of data in that. So for instance, one group talked about how many likes that a person had on an Instagram photo for their survey question. So as another set of data, they could also ask how many followers they have, because we might assume that those two things are related. So they could kind of graph that using a scatter plot. And of course in business and things like that, we would see these as well. And that is it for today. Thanks. Have a good day.